All right, here we go, guys. All right, guys. Some of you have been using TI Inspires, and I'm scared that you guys don't know how to use your TI Inspires.
Nobody uses Inspires.
You need a minimum. No, there's like 3 of you. You need a minimum of 3 digits after the decimal point, and sometimes the TI Inspire will just give you 1 or 2, and you guys still write 2 digits. So.
Doing that, but you can change the degree level, and it will give you more.
Okay.
Ask people to raise their hands.
All right, guys. And then, do you guys know how to store from a graphing the intersection to the home screen? It's stored at x of c. All right, just making sure because I want to make sure you get your points. All right, here. If you guys are using Inspires, continue with the Inspires. Question number 1. Let R be the shaded region bounded by the graphs y equals square root of x and y equals e to the negative 3x. And the vertical line x equals 1, as shown in the figure above. Find the area R. The first thing you need to calculate, they let you use the calculator, you need to calculate the a value here, that x value. So, I'm going to type both of these. I'm going to put this one in y1, and I'm going to put this one in y2. I would not use that notation. I'm just doing that for you guys so you guys can insert into the calculator. If you have an Inspire, it'll be f of 1 and f of 2. So here we go, y equals square root of x. And in the second one, I'm going to put second e to the negative 3x. There it is. And then if I want it to look like this, look, they're giving you a hint on how the window looks. Window, I'm going to go a little bit to the left. So I'm going to go negative 0.3 to 1.7, or 1.5. And then x scale, it doesn't matter. And then y min, negative 0.3 to 1.5. And then I'm going to push graph. And there's my graph. It looks pretty good. It looks pretty similar to what I have on the paper. I'm sorry, what? Like 1.5. Are we okay so far? All right, I need to calculate this intersection. I'm going to write x equals. I'm going to go second, calculate number 5. And on the Inspire, on the 84, I can just push enter all the way. On the Inspire, you have to go lower bound, upper bound. And you get 0.2387. I'm going to write all the digits that I have in the calculator. 2387341 I'm going to put an arrow, and I'm going to store it to A. So I'm going to go to the home screen. I'm going to push X, and it should be there. There it is. Store alpha A. On yours, if you have an Inspire, I would say X of C, and then store it to A. Sorry, miss. I'm trying to give as much detail as I can. All right, next. I already know this is a 1. So if I want the area of R, you can either say the word area or you can say R, doesn't matter. Area equals integral from A all the way to what x value? 1. And then because they don't have names, they don't say F and G, you're going to have to write the equation that is on top and the equation that is on the bottom. What curve is this one? In red. Square root of x. So I have to write square root of x minus, and then what curve is this one in green? Minus e to the negative 3x. I put a parentheses on both of them, put a dx. You get your point for your integral point, and then you get the other point from the answer. No, if you don't put parentheses, you'll still get it correct. So here we go. I'm going to go math 9, and then I'm going to push alpha a to 1. And then I think, I put that on y1. Alpha trace y1 minus alpha trace y2. Push X, enter. 0.442629. You don't have to put all those digits. How many do you have to put at least? 3. If you have an Inspire, you have to put f of 1, and then you have to put parentheses x minus f of 2 parentheses x. If not, you're going to get an error message.
So on that one, we only put the first 3 digits. Do we round or do we just put 0.44?
Round or truncated. So if you just put 0.442, that's called truncating. And if you put 0.443, that's called rounding. Round or truncated, they'll give you the answer. And there it is, that's full credit. Cool or not cool? Okay, look at the next one. They do not give you the image again. I just did this for teaching purposes. It says, find the volume of the solid generated when R is revolved about, oh, I put an extra space there. That should say about. The horizontal line y equals 1. So here's the horizontal line y equals 1. And I'm going to rotate it. You guys want me to show it spinning the right way, so there it is, spinning the correct way. And let's see, point right here, and then that's a point, and then point down there. All right, so it's going to look something like, and let's see if I can, it's okay, I guess. Not perfect, but that's fine. There's my cross section. Man, my cross sections are starting to look even better every time. I still can't believe I got a D in art. What shape is that? Yeah, a washer. So let's just go right to the volume formula. Let's see if we can figure this out. Volume equals, put the pi on the outside. Oh, I need to know where I already do. I already have it. Intersection, because I already calculated this intersection, I already calculated it. You don't have to disable it again. You can just put A to 1. This one, I would put a giant parenthesis because of the pi on the outside. My big R is the distance. So here's where I confuse you guys. Let's just do this curve minus this curve. That's all you got to do. The big R is that in black. Do you guys see that in black? All right. So that is what minus what? Perfect. 1 minus e to the negative 3x. It's just one curve minus the other. Square it. Does that make sense? That's big R. I squared it because it's pi r squared minus little r squared. Pi, then big R squared minus little r squared. It's a washer. So here we go. Minus, and then the little r is this in red. So again, that is 1 minus, and whatever that curve is, and then put a square on it, and then giant parenthesis dx. Cool or not cool? Cool. You put it in the calculator. Don't forget the pi. And let me see if I can do that. Second pi, math 9. Alpha A to 1, and then open parenthesis, 1 minus, I believe that's in Y2, alpha trace Y2, don't worry, we're almost done, guys, squared, minus 1 minus alpha trace Y1 squared X. And I got this. Volume equals 1.423558479. You don't need all those digits. You just need the first three. Yeah, if you wrote 0.423 or 0.424, those are both correct. How do we feel, guys? Is this making sense to you guys? All right. Bless you. Salud. Bless you squared. That's not the corona, right? Okay. Letter C. The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis, it's perpendicular to the x-axis, guys, so I would underline that, is a rectangle whose height is 5 times the length of its base in region R. Find the volume of this solid. All right, here's my cross-section. It's coming out of the board. Do we understand that? Yeah, they told me it's perpendicular to the x-axis. That's my cross-section, and it's coming out of the board. You have a rectangle. So I'm going to draw that rectangle right here. 5 times. That's supposed to be 5 times the height there.
So it's like this, like.
Yeah, this in blue is this right here.
Yeah.
Cool or not cool? How do I find area of a rectangle? It's just length times width. That's it. So here we go. Volume equals, there's no pi anywhere. Integral, again, it is going to go from A to 1. All of them is from A to 1. And you already defined what A is in the very top, so you're good. And then length times width. So the length, I'm going to open a parenthesis, and I'm going to say, what was that top curve? Square root of x minus e to the negative 3x times 5 square root of x minus e to the negative 3x. Before I continue, close dx. I'm going to explain what that means, because I can already see some of you saying, I don't know, what's going on? They told me that the height was 5 times the base, yes or no? Well, this side length, the base, is just square root of x minus e to the negative 3x. Does that make sense? So if I'm 5 times that, there it is, 5 times that. Cool. Cool or not cool? So this is my integral that will give me my volume. What's up?
Did you just like put the square root of x minus e to the x in square?
Yes, that's what I was about to do, miss. You're already one step ahead of me. Here we go. To make it simple, I'm going to say volume equals, you can put the 5 on the outside or you can leave it on the inside. It does not matter. 5 square root of x minus e to the negative 3x close it squared dx. I would probably put the 5 on the outside. And then I just write what that volume is. So here we go. 5 math 9 alpha a 1 open parenthesis, and that is, what is it, y1 minus y2? Alpha trace y1 minus alpha trace y2 close squared. And if I didn't make any mistakes, 1.55435. How do we feel? All right, I'm going to check our answers to see if ours should pretty much look verbatim. It should pretty much look the same, guys. So let me check our answers. I'm going to go to the scoring guidelines. Here we go. Don't worry, we're almost done, guys. We just got these 2 questions. No, they didn't give us units. But if you were to put units, you would put units cubed. Scoring guidelines, 2000. What year again was it? 2003? All right. Here we go. Why are they going so slow? Okay, here we go, guys. Did we get number 1A? All right, guys. Notice they wrote 0.442 or 0.443. 1 point for the integral, 1 point for the answer. Cool or not cool? Note, look at this. Number 1, correct limits on the integral a, b, and c. They use the letter t. Man, that's lame. Why did they use the letter t? Who knows? Let's see, letter b. Did we get, they put it in terms of pi and in terms of decimal. 0.453 pi or 1.423 or 1.424. Did we get that? And then they give 1 point for reversal if you messed up with the ones or whatever. No big deal. And then finally, letter C. Did we get 1.554? There it is. They put the 5 inside the integral. I think that's a little lame. And bless you. I don't like that they use the letter T. I just would go down the alphabet, but whatever. Cool or not cool? All right. Do we see how we do it, guys? All right, let's do one more. So you can see it's not that bad. This is the question we did yesterday, probably the one that I confused the most. So I decided to do it. And I noticed that I didn't write letter C in there, and I don't know why I did that. So I put letter C back in there so we can actually do it. All right, this is from yesterday. Let f and g be functions, f of x equals blah, g of x equals blah. The graph f and g are shown in the figure to the right. Letter A, find the area of the shaded region enclosed by the graph f and g. Simple. That's a 0. That's a 1. The area equals integral from 0 to 1. What graph is on top? F of x minus g of x. I will put parentheses. You don't have to. If you just write f of x minus g of x with a dx, they will count it right. But remember, the whole notion is width times height, width times height, width times height. So the dx is supposed to be like width, and the f of x minus g of x is like height. It's infinite number of rectangles that you're adding up. So I would use parentheses, but you don't have to. Sorry. Cool or not cool, guys? All right. Letter B, find the volume of the solid generated when the shaded region is enclosed. We didn't find the area. You found it yesterday. It's okay. So I said yesterday this was like a 2. I changed it to a 2. You guys remember that? And then I drew that. Yes, ma'am. Yeah, you got to find the area. I don't know what that number is. We found it yesterday. I just did it so I can keep going. Here we go. Y equals 2x parenthesis 1 minus x. And then the next one, 3 parenthesis x minus 1 close square root of x. I don't think I see any mistakes there. Y1 minus, math 9, 0 to 1, and alpha trace y1 minus alpha trace y2 and you put x here, and you push enter, and there it is. So we get 1.1333. All right, on letter B, we're rotating about y equals 2. So it's going to look something like this. Let's see, point. It's going to be something like, and then it looks like it's kind of like a hump there. Something like that.
You just changed the 1 to a 2?
Oh, I just made it, yeah, because I don't have enough room. So I'm just spinning it about y equals 2. So there I am spinning it, and when I spin that, what shape is that? Yeah, I should have done it with a different color. My bad, guys. It's a washer. So here we go. Volume equals pi integral from 0 to 1. And my big R is the distance from here. That in blue right there. So that's your big R. So that curve in the top is 2 minus, what's that curve? G of x, close, squared. Minus, that's the big R. Now here comes the little r. The little r is this distance in green. Bless you. 2 minus, what's that other curve? F of x, put a square, dx. Cool or not cool? And then you guys can do the putting that into the calculator, right? 16.1 79 20316. The more digits, the better. Here you go, Miss Villanueva. All right. Here we go. I'm going to go slow and relax. It's not that bad. You can get the points. You can get all the points. Let h be the function given by h of x equals kx 1 minus x between 0 and 1. For each k greater than 0, the region, not shown, we're going to talk about that right now, enclosed by the graph h and g is the base of the solid with square cross-section, perpendicular to the x-axis. There is a value of k for which the volume of this solid is equal to 15. Write, but do not solve an equation involving an integral expression that can be used to find the value of k. Okay. You actually know how this graph looks. They said for all values bigger than 0, right? Well, notice, doesn't that look a lot like f of x? Look, that's like a k. Kx 1 minus x. You guys see that? So it looks a lot like this. If it's a 3, it's probably going to be bigger. If it's a 4, it's going to be bigger because it's a vertical stretch. If it's a 5, it's going to be bigger, but it's going to look like this. Yay or nay?
Yeah.
Perfect. So what do I have coming out of the board?
Like
Yeah, they're squares. So I guess I'm going to erase this one right there, guys, so we can do a cross-section real quick. So look, it says right here, underline this, with square cross-section perpendicular to the x-axis. So I'm just going to draw it.
It's going to tell us what shape?
Yes, it will always tell you what shape. Always. So this cross-section right here, that line is a square coming out of the board. Yay or nay? All right, now remember when I told you that you can just use letters to express integrals? On this one, you got to show the k because that's what they want to solve for. So we got to be very careful. Oh, did I say that? Okay, sorry. Volume equals, there's no pi, these are squares. I'm going to integrate from what to what? 0 to 1. And the curve up here, that's not f, that is what curve? H. So I'm going to write h of x minus, and what's the curve down here? G of x, and all this is going to be squared because it's a square. Cool or not cool? Now, some of you are thinking, oh, I'm done. That's full credit.
No.
If not, why not?
15.
Okay, it equals 15, and what else do I got to see within the integral? I got to see what?
K.
You got to see k. If you don't see the letter k, you can't get full credit. Does that make sense?
Just write out the equation.
So you just write out the equation. So you say 15 equals integral 0 to 1, open parenthesis, and then write what h of x is. Kx 1 minus x, close, minus, and then what is the other graph? 3 times 1 minus x, close, square root of x.
X minus 1.
X minus 1. Was that it? Let me just scroll up so I can see it. Square root of x, okay. Close. Let me make sure, let me label my, yeah, maybe. There. Now no one's confused.